The questionnaire says that monochromatic light of wavelength 6 to 3.8 nanometer is produced by helium neon laser. The power emitted is 9.42 millivolt watt, and we have to find out what is the energy and momentum of each photon in the light beam, and we have to find out how many photons per second on average arrive at the target irradiated by this beam, and we have to find out how fast does the hydrogen atom have to travel in order to have the same momentum as that of the photon. So here at first we have to find out energy and momentum of each photon in the light beam. So the energy of each photon is given by h nu. This is the Planck's equation. So where h is the Planck's constant and nu is the frequency of the radiation. So nu can be calculated as speed of the radiation divided by its wavelength, and we have been given the monochromatic light of wavelength. So the value of lambda is given over here, the value of h is known, and the value of c is also known, that is 3 into 10 to the power 8 meter per second. So substituting the values, we will get a value of energy of each photon. Now the momentum of each photon is given by the mass times its velocity, or we can calculate the momentum by the formula of p equals to E by c, which is we have already calculated the value of E, that is energy of each photon, and dividing it with the value of the speed of light, we will get a value of P equals to 1.05 into 10 to the power minus 27 kg meter per second. Now we have to calculate what is the number of photon per second, what is the throughput of the number of photons. Now we have got a value of each photon, a value of energy for each photon, and we have been given the power of the radiation. The power emitted was 9.42 into 10 to the power minus 3 watt, and we know the individual energy packets, the value of energy of each packet. So if we divide the value of power by the energy of each packet, then we can get the number of photons per second. So the value of power is 9.42 milliwatt. So 9.42 into 10 to the power minus 3 watts divided by energy of each photon, and we get a value of 3 into 10 to the power 16 photons per second. So the number of photons emitted per second is 3 into 10 to the power 16 photons per second. Now the third question was, what would be the velocity of, how fast does hydrogen atom have to travel in order to have the same momentum as that of photon? So we know the value of the momentum of that of the photon. Now we have to calculate what would be the velocity of hydrogen atom for having same momentum. So momentum is given by mass times velocity. We know the value of momentum of photon, that is 1.05 into 10 to the power minus 27 kg meter per second. We know the mass of hydrogen. So if we substitute the mass of hydrogen over here, we can get the velocity for which they should have the same momentum. So dividing this momentum by mass of hydrogen, we get the value of 0.63 meter per second. Thank you.